Well, there have been quite a few updates on the Lynx program since the last time that we've talked to you. Can you tell us a little bit about the engine testings that you guys have been doing, the rocket firings with the actual fairings and everything?
Well, we've integrated the propulsion system on the back of the Lynx fuselage, and we recently completed our first series of firings with the pumps, both the fuel and oxidizer pump, integrated with the rocket engine and driving it. And to us, that's a big milestone because we've took one step forward with the rocket racer when we were pumping the fuel and learning how to start and stop and synchronize everything properly with both propellants pumped with a piston pump, which as far as we know is the first time that's been done, was quite a step forward for us. And it's really the next to last major milestone before we can declare the propulsion system all done.
Wow, very good. Now, I understand too that you guys have been able to finalize the design on the aerodynamic concepts and been able to add different features that have been able to make it work. Can you tell us a little more about that?
Yeah, that's mostly been done in wind tunnels, and the Air Force sponsored most of that work, for which we're very grateful. Some of the time we were using NASA's tunnel, and some of the time we were using the Air Force's tunnel. Wind tunnels have a lot of advantages for working out aerodynamic design compared to CFD or other computer techniques, because you can try things. You know, if you come prepared with a lot of different configurations to try or different shapes that you want things to look like, then you can try those quickly in the tunnel and find out what worked. And it was that series that about a year and a half ago now that let us wrap up what we think was the last major unknown in the Lynx aerodynamic design, and that's part of how we decide, okay, it's time to start building it.
Awesome. Now, I also understand that you guys have been able to finalize some of the work on your avionics packages and actually have the instruments working and getting data out of it.
Yep. The lesson learned from our past two vehicles was we needed to really plan out a much more extensive in-flight data acquisition system, because there are certain kinds of interesting behaviors that don't show up in ground test. So this time, compared to the last two vehicles, we planned that all out ahead of time, and we're now using the flight type data acquisition system to take and display data during our test, including the displays that will be displayed to the pilot and the flight test engineer during the flight test program. Those are all working on the bench now too, which is pretty exciting for us.
Wow. Now, I know that there's about a dozen major checklists that you have until you start doing major test flights. And do you foresee any sort of major snags that might delay or cause that 10% that needs to be done to take up a large portion of your time?
Always. If things go perfectly smoothly, that's unexpected. The reason why you schedule tests is because sometimes you don't get what you expected. If you always got what you expected, you aren't doing R&D. So the question is, will we receive kind of the expected number and magnitude of surprises? And that's what we don't know yet.